In this video, I want to give you some examples of some really basic proportion problems. Now, proportions are used most often in real-world situations for applications to things like science and nursing, baking, and construction. But I don't want to get involved in that just yet. I want to practice using the direct proportion and inverse proportion equations to solve some abstract problems just to get the process down pat real fast. So example number 1, we're given 3 pieces of information. Suppose that y is directly proportional to x. When x is 7, y is 2. So this particular x value is paired with this particular y value. Supposing that I change x from 7 to 21, how does the y value also change? Okay. Now the first thing that I'm going to do is I'm going to take this statement about direct proportionality and I'm going to translate it into the corresponding equation. And the direct proportion equation is the one where we have y equals k times x, where k is some number. Now that I've set up this proportion equation, let me do a little work to summarize the data that I have been given in the last half of this question. I have been told, let's do a little table of x against y. I have been told that when x is 7, the corresponding y value is 2. Now they want to know, when x is 21, what y value is associated with that? So, having set up our direct proportion equation and having summarized the info about x and y in this table, the next thing that I'm going to do is I'm going to find k. I'm going to figure out what number k must be. And in order to do that, I'm going to use the pair of values x equals 7 and y equals 2 that I was given. So y is equal to 2, so I'll plug 2 in the y's position. K is what we're trying to figure out. And x is equal to 7. So if I divide both sides by 7 in order to isolate k, I find that for this particular problem, k equals 2/7. Now once we have figured out the value of k for this problem, we can use k and we can use the given x to find the new y. So y, whatever it is this time, is equal to the k value for this equation multiplied by the x value of 21. Now we can simplify this a little bit. 7 goes into 21 3 times. So this is equal to 2 times 3. So y is equal to 6. And so we could say, okay, the y value associated with x equals 21 is 6 in this problem. And that would answer the question. Let's do one more example. Suppose that y is directly proportional to x. When x is equal to 3, y is equal to 1. What happens if you change the y value to 5? What happens to x then? So here's our direct proportion equation. Y equals k times x. And let's make a quick table to summarize the data that we have been given about x and y. When x is equal to 3, y is equal to 1. And we want to know when x is what? Y will be 5. When we change y to 5, what happens to x? So let's start by finding k. Finding the k value for this problem. So I'll plug in y equals 1 and x equals 3 and solve for k. If I divide both sides by 3, I get k is equal to 1/3. Next, let's find the missing value of x. So I'll plug in that the y value is equal to 5. We found the k value is 1/3 times x. Let's solve this for x. In order to isolate x, we need to divide out this multiplied 1/3. So it may be easier to write this as x equals 5 divided by 1/3, here using this division symbol. Because for me, it's a little bit easier when I see that division symbol to remember that I can multiply by the reciprocal, and I get x equals 15. X equals 15 is the x value that is associated with this new y of 5 for this particular problem. Now let's do one more with an inverse proportion. They say that y is inversely proportional to x. We're also told that when x is 2, y is 7. So what happens to the y value when the x is changed to 1? So our inverse proportion equation this is equal to y is k divided by x. Inverse proportion, divide k by x. And we also have our table, which says that when x is equal to 2, y is 7. When x is equal to 1, what's y? So let's find k by plugging in 7 for y, by plugging in 2 for x, and we can eliminate the divided 2 by multiplying both sides by 2. So k is 14. 2 times 7. Finally, let's find the missing value of y, find the new y. So we are told that y is equal to k equals 14. X is equal to 1 this time. X is equal to 1. And so the new y value, 14 divided by 1, is just 14. That's the y that goes with x equals 1 based on this equation.